Can you guys see the screen?
Yes.
All right. So আজকে আমরা যেটা করব, what we'll be doing হচ্ছে will be, last time around we talked about friction, limiting friction. Uh, we discussed about how limiting friction is the maximum possible friction that two surfaces can have between them, and it depends on the normal contact force and the coefficient of friction. We talked about a few things, and we also discussed how inequalities may get involved when it comes to situations like this. So I'm going to take a look at this particular question from summer 12, 4-3, and hopefully this will give you a, sort of an overview of how to tackle questions like these. All right. And you can see that this clearly has some element of friction in it. In fact, you can see mu being the coefficient of friction, right? All right, so let's go over this question and solve it real quick. A block of weight 1.6, oh, sorry, 6.1 Newton is at rest on an inclined plane, where the value of tan alpha is given. The coefficient of friction is given as mu. A force of 5.9 is acting parallel to the line of greatest slope. Okay, so there is friction. Question number one. When the force acts up the plane, the block remains at rest. Show that mu is greater than equals to 4 by 5. Now, initially, this might be too scary, so I'm just going to try to see what we can deduce so far. So this is alpha, and this is a 5.9 Newton, all right? And we have mg sine alpha acting in this direction, mg cos alpha acting in this direction, and of course the normal contact force. Now, what else do we know? We know that tan alpha is equals to 11 by 60. Okay. And we also know that, what else do we know? The weight, we know that the weight is 6.1. All right. We also know that mg is equals to 6.1. So what can we say about the friction? All right. Before we can say anything about the friction, it's a good idea to figure out this opposing value. All right. So this is going to be 6.1 times sine alpha. Now there are many ways you can go about finding the value of sine alpha. I've shown you already that using the sine square plus cos square formula, you can figure out the values, exact values of sine alpha and cos alpha. But what about tan alpha? What if tan alpha is given to you? Well, one way to take a look at this is this is alpha, tan is opposite by adjacent. So that would mean opposite by adjacent, right? In a small right angle triangle. Now, using Pythagoras, you can figure out this hypotenuse length, and this hypotenuse is root over of 60 square plus 11 squared. And that is essentially, you need to put this in your calculator. What do you get?
61.
61. So that is exactly 61. All right. Now, with this tiny little figure in your rough working, you can straight away say sine alpha is opposite by hypotenuse, that's 11 by 61, and cos alpha is adjacent by hypo, so adjacent by hypo, that's 60 by 61. And a method you can also use, a small right angle triangle method you can also use, if one of these is given and you need to figure out the other, এটা দিয়েও করতে পারো। লাস্ট টাইম যেটা দেখাইছি sin square plus cos square, ওইটার বদলেও এইটা করতে পারো। So this is a formula you can follow all throughout, right? So with this in mind, let's do the math and figure out what the value of mg sine alpha is. 11 by 61, and this should give you a value of what? 1.1, I think. এটা একটু করে দেখো, হ্যাঁ 1.1 Newton. Now, straight away, you should get the feeling. Look, someone's pulling the block up 5.9 Newton diye, and someone's pulling it down 1.1 Newton diye, and that's the weight, obviously. Why on earth is the block still at rest? It must be because there is a friction in this direction as well. So we know from the question from part 1 that the block remains at rest. So it must mean 1.1 plus friction is equals to 5.9. So friction is equals to 4.8 Newton. Now, notice from the question that nowhere in the first part or in this scenario, nowhere do they mention that the block is in limiting equilibrium, nor do they say in the first part that the block is moving. So we cannot say for sure that the 4.8 Newton is exactly limiting. So not sure this is mu r. ঠিক আছে? But what can we say? We can say that 4 the 4.8 Newton that we just found, which turned out to be the friction in this case, may be equal to the value of mu r. Maybe it is the maximum possible friction, but is also there is also a chance that this 4.8 may be less than the mu r value. হতে পারে যে the maximum possible friction in this situation was not required. So 4.8 was not the maximum possible friction. So can I not say that 4.8 is less than or equal to the maximum possible value, right? So 4.8
Yeah.
is less than mu into r. Now the value of r, if you take a look at this, we said r is compared to these forces. Now R is equal to mg cos alpha. Now mg cos alpha is 6.1 into 60 into 6 uh, into 60 by 61 mg cos alpha. So this gives you a value of 6. So 4.8 is less than equals to mu into 6. And when you do the math, and if you make mu the subject, you'll see that it boils down to 4.8 divided by 6. If you change it to whole numbers, 6, 0.8, it's 0.8, and 0.8 in fractions is 4 by 5. So this is how you solve it. Again, এখানে the idea was you have to draw the diagram, figure out the forces, and realize that there has to be a friction downwards if I want to balance these out. And then I figure out the necessary value. And then I ask myself, what is this value when it comes to limiting friction? Well, the answer was it could be limiting friction, the equal to sign, but it could also be less than limiting friction. Less, obviously, আমার ফ্রিকশনটা limiting friction এর কমই হতে হবে. And then I solve this inequality, getting to this answer. এতটুক পর্যন্ত কারো কনফিউশন আছে নাকি?
Uh,
আচ্ছা, now this was the case because আমাদেরকে বলছে the block was at rest and nothing about limiting friction or limiting equilibrium was specified, and that is why the uncertainty, right, যে could be greater than, could be less than, but could be also equal to. Now what about the next question? Now the next question says suddenly they change the direction of the external force. The force now acts down the plane, the block slides downwards. Now if that is the case, show that this happens. Now, if you know that the block slides downwards, you just know that the block is moving. All right, you know nothing else. তখন কি হবে? Well, here's the block, and we know mg sine theta gives you a value of 1.1 from the above working, and um, we've also seen j 5.5 point. Oops, just a second. We've also seen that 5.9 5 1.1 and 5.9. Acha, something's wrong. just a minute. Sorry about that. Okay. So we have 1.1, which is mg sine theta, and the 5.9, which the question has added. So that's 7.0 Newton, right? And we now know that it is moving down the plane. Okay. And and since it's a rough surface, we know that there's going to be a friction acting. Now here's the interesting part, guys. Since the question said it is moving, we know that the friction must be the limiting friction, right? The friction must be the limiting friction. We already know that from our previous lecture. We've learned that if an object is moving, it has surely overcome the maximum friction and thus have started moving. So we can definitely say that um, the friction is less than 7.0, or 7.0 is greater than the friction, meaning this downward force was obviously greater than the friction and thus the movement down the plane, right? Now, and we also know that the friction must be the limiting friction. So I can write this. I'll start from this. তুমি যে কোনো একটা দিয়ে স্টার্ট করতে পারো, যে ফ্রিকশনটা যেহেতু লিমিটিং হতে হবে, এই ফ্রিকশনের জায়গায় I can substitute mu r, and I know that mu r has to be less than 7.0. কেন? Because a 7.0 overcame the maximum possible friction mu r and then went down. So what do we know about mu? We don't know much about mu. We can acha acha. So first of all, we know that the only reason the block is moving down is because the downward force overcame the upward force being friction. And thus we can write this inequality. Friction was less than 7. Now we can't say যে friction was less than equals to 7, because equals to হলে ওভাবে move করতো না, right? So the friction was not enough to balance the 7.0, which was the total downward force, and thus this inequality. From this inequality and our knowledge that for any moving object, the friction has to be the limiting friction, mu r can be substituted, sorry, friction can be substituted with mu r. বলো।
ফ্রিকশনটা তাহলে 7 নিউটনই হলো না।
হ্যাঁ, 7 নিউটন হলে তো ব্যালেন্স করতো, মানে স্টেশনারি থাকতো, অ্যাট রেস্ট থাকতো, অ্যাট লিমিটিং ইকুইলিব্রিয়াম থাকতো, মুভমেন্ট তো হইতো না, তাই না? সো সো এই জন্য ইকুয়ালস টু দেই নাই। সো মিউ, হ্যাঁ বলো।
লিমিটিং ইকুইলিব্রিয়াম তো মানে যে লিমিটিং ফ্রিকশনটা ক্রস করার আগে আগের ভ্যালুটা না।
হ্যাঁ, দ্যাটস লিমিট, হ্যাঁ দ্যাটস লিমিটিং ইকুইলিব্রিয়াম, হ্যাঁ। আচ্ছা, সো এখানে লিমিটিং ইকুইলিব্রিয়াম হতে পারে না, বিকজ ওরা বলে দিছে দ্য অবজেক্ট ইজ মুভিং, and that means the friction was completely outvalued, ঠিক আছে? So the friction value, this is my friction value, was definitely less than the 7.0 that was pulling it downward. So what was the value of normal contact force? Normal contact force was mg cos alpha, as we've seen before. mg cos alpha, normal contact force change হওয়ার কিছু নাই, and এটা দেখছি যে কত 6 আসছে, 6 আসছে value. And when you make mu the subject, কত আসে 7/6 আসে, when you make mu the subject, you get mu is 7.0 divided by 6, ঠিক আছে? So এখানে আমরা convinced that the friction was limiting because of the movement, and we were also convinced যে less thanই হবে because it overcame the limiting friction and went into motion, ঠিক আছে? Any question regarding that part? আচ্ছা, given that the acceleration of the block is 1.7 when the force acts down the plane, meaning in figure 2, find the value of mu. So that's pretty simple because, whoops, because resultant force is equals to mass into acceleration. আমার বড় ফোর্সটা হচ্ছে 7 নিউটন, ছোট ফোর্সটা হচ্ছে ফ্রিকশন। সো বড় ফোর্স মাইনাস মিউ আর, রাইট? মিউ ইনটু আর হচ্ছে the normal contact force, আমরা দেখছি it came out to be 6 mg cos alpha, is equals to the mass. The mass was 6.1, যেহেতু weight ছিল, the mass was 6.1 by 10 into the acceleration. Accelerationটা ছিল হচ্ছে 1.7. Since the weight was 6, whoops, since the weight was 6.1, the mass is 6.1 by 10 and the acceleration was 1.7. So I'm going to put 1.7 here and I'm going to make mu the subject, and that should give me some value. And that should give me the answer. So this is how you tackle questions related to limiting friction. All right. So any questions? All right. Um, if you guys have no other question, I will give you. হ্যাঁ বলো।
এটা F is equal to ma ফর্মুলা ইউজ করেছো না?
হ্যাঁ হ্যাঁ, F equals to ma, resultant force equals to mass into acceleration।
7 minus mu into 6,
জি।
এটা কি ফ্রিকশনের ইয়ে না?
হ্যাঁ, সো কেন এটা করলাম, বিকজ এফ মিনস রেজাল্টেন্ট নেট ফোর্স, এক্সেস ফোর্স। সো আমার দুইটা ফোর্স আছিল, ইয়েতে ছিল, ডায়াগ্রামের মধ্যে ছিল, একটা হচ্ছে 7 আর একটা হচ্ছে ফ্রিকশন। এন্ড ফ্রিকশনও আমরা জানি ইজ দ্য লিমিটিং ফ্রিকশন বিকজ মুভমেন্ট হয়েছে। সো দ্য রেজাল্টেন্ট ইজ গোয়িং টু বি বড় ফোর্স মাইনাস ছোট ফোর্স, এই যে বড় ফোর্স মাইনাস ছোট ফোর্স ইজ ইকুয়ালস টু এম এ। So if you have no other question, I'll ask you guys to solve a few questions. ঠিক আছে?